All right, we are continuing to look at special products of polynomials. We are to the modeling real life example. So here's example 4. A combination of two genes determines the color of a dark patch on a border collie's coat. Each offspring inherits one patch colored gene from each parent. Each parent has two patch colored genes, and the offspring has an equal chance of inheriting either one. Each parent has the same gene combination, capital B, lowercase b. The Punnett square shows the possible outcomes for the gene combinations of the offspring. So you can have capital B, capital B, lowercase b, capital B, or lowercase and lowercase. You can see that the first three result in black and the last one results in red. So here you go. What percent of the possible gene combination result in black patches? All right, so let's look at A part first. What percent of possible gene combinations results in black patches? So 1, 2, 3 out of 4. So if we do 3 out of 4, as a percent, that is 75%. So 75% results in black patches. So you can safely say that there are more possibilities of a border collie having black patches than not. All right, so show how you can use a polynomial to model the possible gene combinations. All right, so since we have one parent has a capital B and a lowercase b, the other parent has a capital B and a lowercase b, then we can use what we've been looking at as capital B plus lowercase b squared, because we have this side times this side, which is the same thing as our binomial squared. All right, so if we got capital B plus lowercase b squared, we know from our combinations we've been looking at, our patterns, we can do capital B squared. We can do 2 times A, which is capital B, times B, which is lowercase b, plus lowercase b squared. So that's going to equal capital B squared plus 2 capital B lowercase b plus b squared. So that's exactly what we've been doing in all the other examples. All right, so since they told us that the offspring has an equal chance of inheriting either gene, that means capital B is 0.5 or 50% chance, and lowercase b is 0.5 or a 50% chance. So if you want to evaluate each term of the polynomial, you can do that. You can do b squared. Capital B would be 0.5. So we could do 0.5 squared, and that equals 0.25. So that is 1/4. So that's 25% would have capital B times capital B. So it would be 25% would be capital B and capital B. All right, if we want to look at the middle term, it's going to say 2 times capital B times lowercase b. So we already said that each one is 50% chance. So let's say 50% chance and another 50% chance. So 2 times 0.5 times 0.5 would be 50%, because this is going to be 0.25 times 2, which would be 50%, that it's going to be capital B and lowercase b for the black patches. So this one is black, and this one is black patches as well. And then we're going to look at the lowercase b. It's lowercase b squared. So again, lowercase b is 0.5. We're going to square that. 0.5 squared is 0.25. So that is the same as having 25% of lowercase b and lowercase b. So that is going to be the red patches. So this shows you the exact same thing as the little chart up here. So if 25% is capital B, 50% is capital B, lowercase b, 25 plus 50 is 75% of the possible gene combinations results in black patches. And this also shows that 25% results in red patches, which 1 out of 4 is 25%.